Okay, so what it becomes? It will become R2, right in the middle is CHO, and then R1. In order to help you understand this one, we don't draw like this. We draw CH like this. Okay, now this guy, you can write it like that. What will happen? If they find another free radical, they will generate R3H and R2, R1, right in the middle is this guy. What's that? That's ketone. They also could be, if this is R2, C carbonyl group, H, so you go here, you have R1, and we find another fatty acids chain, R3H. What will happen? What are they going to do? This will go here. Then becomes what? R1 become H. Then you go here, H. Then you go R2. Alcohol. And this guy here is RH3. Switch. Okay? That's what happened for the deposition. So two deposition will happen in the alcohol and the aldehyde. They will switch. So this is what will be happen. Have alkyl ketone generate, have alcohol generate. Okay, so we gave you an example of here. What do we left to talk about? We talk about this oxygen, this is triplets. If you have a photosensitizer or photosensor, it will not follow Pauli exclusion policy, will generate a singlet oxygen. This singlet oxygen, we say the electron arrangements in the sublayer orbital is matching the sublayer orbital of the double bonds in the unsaturated fatty acids. So they will generate different isomers. We call resonance. So they will generate for resonance. And we will give you an example. Actually, two examples here. Okay? What happens in example number one? Oleic acids. Still using oleic acids as example. Okay, oleic acids, we have to draw the whole thing in order to explain. COOH. Go here, go here, go here. 2, 3, 4, 5, 6, 7. We'll just draw on the top. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, go here, 18. There's double bonds. Okay, what happened during the free radical generate? we're gonna focus on here. Okay, not draw everything. What happened at the beginning? This guy right here, at the beginning, they could generate, this is 8, 9, 10, 11. They will easily have our first free radical is this guy. And they also, at the same time, now by the way, this 8 is called a methylene interfered CH2. They could also, at the same time, generate the position at 11. Okay, so this is 9, this is 10. This is the position at 11. Now what will happen? This go down, this go down. They will go through isomerization process. Because of the single letter oxygen, they could be easily reacted with here. Not only have the cis configuration, they will generate trans configuration. So what it looks like. Go here. What happened? For this guy, 8, 9, 10, 11, the free radical goes here. The double bonds will be migration, goes here. And how about that one? You have 8, 9, 10, 11. What's the position we haven't talked about? 9. And this double bond will go here. So this is from cis to trans. And the research has been showing in oleic acids, in a sunflower oil, if this happens, trans 90%, cis 10%. That means if the sunflower oil has been oxidized, majority of them, more than 90% of the resonance, it is trans fatty acids. So anyway, you cannot eat it, regardless of the quality. And these 4 will go through all this process again. So at the end of the day, you will generate 4 hydrogen peroxide. That's what happens. The 4 hydrogen peroxide will be generated. Our textbook is made a mistake. They write they will generate 3 hydrogen peroxide. Actually, it will generate 4. Okay, now, I'll let you think. I'll talk afterwards. Example 2. Linoleic acids. By the way, let's just review it. Linoleic acids, what they call it? Cis 9, cis 12, octa, deca, diionic. So what's linoleic acids looks like? And you can go ahead to do the quiz by yourself. So we go down. 3, okay, 2, 3, 4, 5, 6, 7, 8, 9, double bonds here. So go down, go up, 10, 11, 12, 13, 14, 15, 16, 17. How many they will generate? They will also generate 4 resonance. But so you're not going to generate it at the position 8 and 11. They will generate at 9, 10, 12, and 13. Where are they? If this guy happens here, this goes here. If this happens here, This goes here. Skip this one. If this happens here, this migrates to here. If the last one happens inserting, this goes here. There are 4 resonances. If you are faculty, you're teaching at Utah State University for food chemistry, you could give them a quiz. How many resonance will be for linolenic acid? Because there is one more double bond there. How many? 6. Is that right? You can do it. You can draw that. I checked our textbook, maybe wrong, maybe clear. Even the labeled number is incorrect. But you can do it. Now, at the end of, before we finish, I want to say why this will happen. Because we go back to single-letter oxygen. What's the single-letter oxygen talk about? They did after the photosynthesizer in the food products, they reacted with light, they will become unfollowed Hans-Luz and Pauli exclusion policy for the electron orbital. So the orbital electron spin. So they make it be energized. These is we call it a ground status or base status. Nothing, we're very quiet, and this is energized. That's the reason. Okay, so this is what I have for the lipids oxidation.